talk about welding, welding differs from soldering and brazing in one particular way. In fact, soldering and brazing are just about indistinguishable from each other, except that we have sort of drawn this line in the sand. The difference between soldering and brazing is actually temperature. The term brazing refers to brass, melting brass in to fill in gaps and that sort of thing. But there's so many different varieties of brass and things that are sort of like brass but not brass, and really the technique and how you do it depends more on the temperature. So we'll differentiate brazing from soldering based on the established temperature difference. If you're above 840, if the filler metal has to be above 840 F to melt, then you're brazing, whether or not it's actually brass that you're using. What soldering and brazing have in common is they're effectively using liquid metal as a glue. We're supplying molten metal to try and glue two parts together. So it's working as an adhesive, basically. We're not melting the base material. If you're melting the base material, then you're welding. So what if we get a brazing torch and some brass filler rod and use it to repair a brass trombone? Is that brazing? No, that would be welding. Welding is differentiated from the other two. We're fusing the base metals together rather than applying some additional metal just to kind of hold it all together like an adhesive would. In welding, you're actually melting the base materials together. So if you're brazing two steel parts together, then that's brazing. But if instead of two steel parts you put two brass pieces together in exactly the same way, you're not brazing, you're welding. So that's what welding means, melting the base materials. And it doesn't matter if you add filler metal or not, melting the base materials together is the point. Fusion of the materials can be accomplished through compression, friction, flame, or electric heating, and several other different modes of heating. So usually we differentiate these processes mainly based on how the energy is supplied. It could be a flame, it could be an electric arc, induction loops, just like an induction stove heats things up. Explosive charges can create pressure and compression. Spinning one workpiece against another could create enough heat to melt them together. Stir welding is kind of it's not a new process. It's like everything. It's existed for 40 years, but now we're starting to use it more. Stir welding is done by, if we have two pieces of pipe joining each other, and we just butt them up against each other with no gap, no other prep. They're just two clean, sawed-off pieces of pipe. We can take a rotating tungsten bit, usually it looks something about like that, has a bit of a point on it, and spin this thing at, several thousand RPM, and that tungsten bit we can then press down into the parts, and it's going to create enough friction to melt its way through the parts. So we can use this to make a hole if we want, so tungsten drilling is a thing, and it has some advantages over. It doesn't actually remove material, for example. It just pushes the material out of the way. So, well, this is a bit of a side, but if I have a flat plate of metal and I drill a hole in it, then I've just got a flat piece because I've removed material. But if I drill it with a tungsten stir bit, then the metal that's moved out of the way gets piled up along the edges here. So if I want to come in and put a fastener in, this is a good way to do it because it actually builds up the edges instead of removing the material. Well, the same applies here. Where you start this stir weld, you may get sort of a buildup of material and a stir weld or a stirred hole, or tungsten drilled hole, if you like. But then if you rotate the workpieces under the bit or drag the bit through the workpieces, you can actually melt your way across this. And so it then becomes kind of a mixing process where we're just dragging this cylindrical thing through the material, and it leaves a trail behind it of melted material. So that is stir welding. And it's usually a computer-controlled process to get the movement, speeds, and accuracy that you need, though obviously you could try and do it mechanically if you wanted to. So a lot of stir welding is sort of the modern computer-controlled stuff has allowed it